Quantum physics, also known as quantum mechanics, is a major part of modern physics along with the general relativity. Quantum mechanics is the branch of physics relating to the very small particles. It results in what may appear to be some very strange conclusion about the physical world. At the scale of atoms and electrons, many of equations of classical mechanics, which describe how things move at everyday size and speeds, ceases to be useful. These properties include the interaction of the particles with one another and with electromagnetic radiation such as light, X-rays, and gamma rays. Quantum physics is arguably the greatest intellectual triumph in the history of human civilization, but to most people it seems like it's too remote and abstract to matter. When we talk about quantum physics, we usually emphasize the weird and counterintuitive phenomena, such as Schrodinger's cat in a superposition of life and death, Einstein's objection to God playing dice, and the weird long-distance correlation of quantum intellectuals. In fact, quantum physics is all around us. The universe as we know it runs on quantum rules, and while the classical physics that emerged when you apply quantum physics to enormously huge numbers of particles seems very different, there are lots of familiar everyday phenomena that all are existent to quantum effect. The example of things that probably run into our everyday life without realizing that they are quantum is fluorescent light. The kind of old-school incandescent light bulbs make light by heating a piece of wire hot enough to emit a bright white glow. The fluorescent bulbs, either the long tubes or the newer twisty CFL bulbs. The light produced is from another revolutionary quantum process.
So let me move to the application of quantum mechanics. The light that is produced by the tube or light bulb is caused by a quantum phenomena. A fluorescent light bulb is an idea of black body, which means that it will absorb any radiation that is incident upon it. Black body radiation is produced whenever an object is heated up. According to page 625 and 626 of the Encyclopedia of Physical Science and Technology, the fluorescent light that is produced by an excited scintillator is directed through an appropriate optical medium to a photomultiplier tube. When we heat a light bulb, the current flows through a small wire that is coiled tightly within the glass bulb. This causes the wire to heat up, which in turn causes the fluorescent bulb to produce light. This process can be explained in greater depth below. After that, the light that is produced by light bulb will continue to radiate in a steady manner. The electron found in fluorescent emit heat, which in turn results in the emission of electron. In response, the electrons attack a tiny amount of mercury that is contained inside the light bulb itself. The collisions allow the electron in the mercury to rapidly reach a quantum energy state that is higher than their previous one. Electrons that carry a huge amount of energy have a tendency to decelerate and return to a lower energy state. Then, this process takes place. Photons are released, which tends to lead to the production of the light. For your information, mercury has the ability to produce light at frequencies that are mainly detectable within the visible light spectrum. As a result, our eyes are made to believe that the light is white rather than the red color or another distinguishing color of the light bulb.
So the conclusion is we can consider that one of the great ideas of the 20th century, quantum mechanics, was developed mainly by Niels Bohr, Erwin Schrödinger, Werner Heisenberg, and Max Born, lead to a drastic concept of objective reality. It explains the structure of atoms, atomic nuclei, and molecules, the behavior of subatomic particles, the nature of chemical bonds, the properties of crystalline solid, nuclear energy, and the force that stabilizes collapsed stars. This physics framework is responsible for any number of bizarre phenomena, such as theoretical cats that are simultaneously dead and alive, and particle kilometers apart that can nonetheless communicate instantaneously. But it is also responsible for the technological advance that make modern life possible. Technologies that rely on quantum phenomena are all around us. Other than fluorescence, here are a few examples of things you probably run into your everyday life without realizing that they are quantum, such as toasters, computers, MRI scanners for medical imaging, lasers, solar cells, electron microscope, and many more. These technologies rely on quantum effects that need limited control. By achieving this control, we are able to reach new capabilities for computation, digital communication, sensor technology, and other applications.